For the now solve this, problem 7-3, I'll start by reading the question. It's kind of long. So carbon copy, the first cat produced from a clone, was created from an ovarian cell taken from her genetic donor, Rainbow, a calico cat. Okay, let me jot down some notes here for us. Okay, carbon copy, which is a cool name for a cat, I think. Carbon copy. It's a cloned cat. This is a true story. Okay, cloned cat. It was created from an ovarian cell taken from her genetic donor, Rainbow. Rainbow, ovarian cell. So the cloned cat was created from the ovarian cell, and Rainbow is a calico. So patches of white, black, and red. Okay, so the diploid nucleus from the cell, from the ovarian cell, was extracted and then injected into an enucleated egg. So they took an egg from another cat, or maybe from Rainbow, I don't know, from well, they took an egg and they just removed the nucleus, and they put in the nucleus from the ovarian cell. So let's say enucleated egg. I don't think it matters what cat this came from, or maybe it does. Maybe we'll see that in a second. So enucleated egg. So no nucleus in there, but we take the nucleus from Rainbow here. Let's call this the R nucleus here. This is from Rainbow. We take this, and then we're going to inject this nucleus into the enucleated egg. That means the nucleus was removed from the nucleus from the mother that donated the egg was removed and replaced with this R nucleus from Rainbow. So the resulting zygote was then allowed to develop in a petri dish. Okay. So no fertilization was needed. So we're just taking a cell from Rainbow, a nucleus from Rainbow, and we're going to stick it in an egg that's had the nucleus removed. And then it's going to develop in a petri dish, and then the cloned embryo, once it starts developing, everything looks fine. They put the embryo into the uterus of a surrogate mother cat who gave birth to carbon copy. Okay, so petri dish, make sure it's okay. Little check mark, okay, it's developing. We're going to put it into surrogate mom. So nice of the surrogate mom to donate her uterus for this cat, for carbon copy. Surrogate mom gives birth to carbon copy. And we can actually see the photo of carbon copy on page 196. Okay, let's take a look here. Hold on a second while I'll pause this and get that photo for us. And there's the picture of carbon copy with her surrogate mom, and carbon copy is really cute, I think. Okay, let's go back to the question. I lost it, so just give me a moment here. Let me pause the video. Okay, I have the question back. So carbon copy surrogate mother was a tabby. Okay, we can see surrogate mom here. That's a tabby cat. Geneticists were very interested in the outcome of cloning a calico cat because they were not certain if the cat would have patches of orange and black, just orange, or just black. Taking into account the lion hypothesis, explain the basis of the uncertainty. Would you expect carbon copy to appear identical to Rainbow? Explain why or why not. Okay, so here's the question. Essentially, what they did was they took a ovarian cell, so a cell from the ovary, and we don't know which cell they took it from the ovary. Lots of different cells in an ovary, right? And there are the cells that the oogonia, right? That produce the primary oocytes, and we don't know which cell they took. But so let's assume that in the ovary, one of these X's is going to be inactivated, and let's say it's the X that has I should step back a bit, right? Just quickly, now take a look at some of the earlier problems, especially the cat breeder problem. So calico cat is going to have on its X chromosome, it's going to have one allele for the red pigment or orange pigment and one allele for the black pigment. And in its cells, its black patches are going to have cells with the X chromosome, with an X chromosome inactivated that has the R pigment. So it's going to be in the bar body, and the active one is going to be the CB allele on the active X chromosome. And red patches are going to have cells where the X chromosome with the B allele, with the CB allele, is inactivated, and the X chromosome with the red allele is going to be active. So when they take an ovarian cell, well, we don't know which X chromosome is inactive, right? Or we don't know, or maybe they're both active in an ovarian cell. But let's assume that one of them is inactivated, and let's say it is the X chromosome with the red allele. Okay, so in this one, the X chromosome with the B allele, the CB, is active. We take this and we put this into an enucleated egg. And then we have a CR here and CB here. Okay, so scientists don't know what's going to happen here. This is inactive at this point. Now, this is going to develop, and normally the two X chromosomes are thought to both be active at this state, and it looks like one is inactive, right? Because we took it from a cell where it should be inactive, and the Lion hypothesis says that once an X chromosome is inactive, each time that cell goes through mitosis, the same X chromosome is going to remain inactive. So if that's the case, then the cloned cat should be only one color. In this case, it would be red. It wouldn't show the patches of both red and black, because the X chromosome is inactivated and it remains inactive. So the other possibility is, in this case, that somehow both chromosomes are activated. So the inactivated is activated, and we just get normal development, and a normal calico cat is produced, or tortoiseshell cat is produced. So I guess what the question wants us to do is, do we expect carbon copy to appear identical to rainbow, a calico, or is it only going to have one color? So if it's identical to rainbow, then what we're assuming is that both the in that donated nucleus, the inactivated X chromosome is going to become activated at some point. So we're going to have two active X's, and then we're just going to get normal development during embryogenesis and development of the kitten, carbon copy, and then we'd end up with a calico cat. So eventually one of the X chromosomes would be inactivated, put in the bar body, in each cell, and this would lead to the calico cat. But in order for this to happen, at some point both X chromosomes would need to be activated, some point between transferring the nucleus from rainbow to the egg and then that egg developing into an embryo. We would need to at some point activate both X chromosomes so they can be inactivated in a random manner. The other possibility is that when the enucleated egg is given the nucleus from a rainbow, and let's say the CR allele was on the X chromosome that's inactive, then every cell from here just has the same X chromosome inactivated. In that case, there'd be no black and red patches. There would just be the black patches, because that every cell has the red allele inactive. So two possibilities. Scientists don't know which one is going to happen, right? We don't know which one is going to happen. We just have to guess. I'm going to guess that it is going to be... No, I have no way. I looked at the picture, but I would have hoped it was this one, because I would like to see both X chromosomes become activated at some point, and then for the process to proceed as normal. So let's see what happens in question 733, which is going to be like the second part of this question.